All right. Hello. Um, Today, doing another depth first search problem with trees. Some root to leaf numbers. Basically, okay, well, I'll just read the question, I guess. You are given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. For example, the root to leaf path 123 represents the number 123. Return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit in a 32-bit integer. A leaf node is a node with no children. So, yeah, you just want to sort of do what we were doing before. Okay, yeah, with finding basically the path. But I guess instead of just finding the path where it does add up to said number, you want to identify that you are at a leaf node, and then you want to just start returning um the sum of all of those numbers. So we'll once again be using recursion. So we'll write the last like answer here later. And we'll just go ahead and define our helper function first. So we'll define this as sum numbers helper, because well, theirs is called sum numbers, and we'll just call it the helper of that. We're going to need to define it in. We need to pass it self because we're doing it within a class solution. We're going to pass it node, which is an optional tree node because it could be none or null. I'm going to pass in current, which is an integer, and we're going to be returning an int. So leave it at that. And like always, we always need to have one of our, what are they called? Edge cases. So basically, if the node that we're currently looking at is null or none, we're going to return 0. And then, so here we need to do a little bit of math, right? So when we first look at this node, we know that we want to add it. We want to add it in like the ones unit level, and then so once we go from here to here, we want this to be 12, right? So we need to multiply whatever we had before by 10, and then we add this again. And so since this becomes 495, right, we start at 0. I guess like that's going to be part of our helper thing later. We're going to start off at 0, we add 4, and when we go to the next node, we need to make this 49, so we need to multiply whatever we had before by 10, make this 40 plus 9. Now this is 49, we want this to be 495, right? So we multiply everything here by 10. So 49 times 10 would be 490 plus 5, 495. And that's how we're going to build out this number as we go down each level. So in order to translate that into our code, we're going to do current equals current times 10 plus node.value, because we know node is guaranteed to like exist, so we can do this. And then if not node.left and not node.right, we want to return current, because we know that means we're at a leaf node and we can start returning our current value all the way up. And so we will go here, and then we'll have to return, because if this isn't true, that means we have at least one child. It doesn't necessarily mean we have 2 children, but we'll have at least one child. So we have to, recursively call our current function in order to start returning like an actual value, right? So we're going to return self.sumNumbers helper. We're going to pass in node.left and current, and we're going to add it onto self.sumNumbers helper, node.right and current. So the reason why we need to do this is, like, let's just say we're at 4. We'll go to the lowest level possible. Actually, no, we'll just do this one because it's the easiest, right? So we call this on 1, and current, we're going to start at 0, right? 0 times 10 is 0 plus 1, 1. it is not like it has children. In this case, we have two, so we won't be returning. We need to go down both, right? And so now we go here to two. So then we pass in one, right? So 1 times 10 is 10 plus 2, 12. It is like a leaf node, so we will return 12, so that's that. And then we need to add this other side, which is 1 times 10, 10, 13. It is a child, so 13. So 12 plus 13, it will return 25, which is what we expect. And I guess the way you want to look at this is like, let's just say 5 has another child to the left, right? Let's just say it's like 1, right? 5, it would still not return here if there's a 1 as a child to it. So it wouldn't return, so we need to call it on both sides. And then we'll return 4951, 4951 plus 0 here. So we'll return 4951, and then we'll just go up here. And then when we get back to the 9, it'll be 4951 plus 491. And then that'll probably all the way back up to like this caller when we called it on the head or the root here. And this will be 40. So that will work out like that, right? And so that's how you know the code works, or I guess that's how logically the code traces. Could be wrong, but okay, that kind of ruins the whole point of the video if I show you a wrong answer, right? So that's how the answer works here. And so we need to call our helper to wrap up the question. So we just call our helper on the root. We start off with 0 because obviously we don't have any values currently. And yeah, so that's how you just essentially wrap up the question. That's why I had to leave it for last, because without any of this written, it wouldn't make sense at all, right? So with that being written out, believe we're good to go. Huh. Awkward. Awkward. Actually awkward. Did I type anything wrong? Some numbers helper. If not node, return 0. Current equals current times 10 plus node dot val. If not node dot left and not node dot right, you return current. And then you return self dot some numbers helper node dot left comma current, and plus self dot some numbers helper node dot right current. And then here at the very top, you do return self dot some numbers helper root comma 0. Okay, you know what? Kind of getting sick of that. I'll just refresh it. It's still the same code. We'll submit again. Maybe you'll actually submit. Oh, there we go. Actually submitted. All right, so that was, I believe, unnecessarily awkward, but yeah, I mean, that's how you do this problem, and thank you for watching.